Hello guys, welcome to this video from Commentary channel. In this video we're gonna continue solving the problem from CLRS textbook, and in this part we're gonna solve the exercise in section 1.2 from CLRS, and we're gonna continue to define the algorithm in technology and computational things. And yes, that's it. Let's solve it together. Okay guys, as you can see, I write the first exercise here. Give an example of an application that requires algorithmic content at the application level and discuss the function of the algorithmic involved. Actually, the answer for this question is that GPS. Actually, we use from GPS every day. We use from Google Map and other things. And we know that GPS devices provide instruction for moving from one place to another in the form of an application, and use algorithms such as the digester algorithm that we use from this algorithm to find the path between two nodes. Actually, the shortest path from between two nodes, and we will read this algorithm later. And yes, that's it. That was the answer for first question. For rest of the question, actually I write them in my whiteboard, and we will continue solving them in whiteboard. So let's go. Okay guys, as you can see, this is the second question. Suppose we are comparing implementation of insertion sort and merge sort on the same machine. Actually, it says that same machine, so the speed of running them is the same because we have same hardware for running this code. And for input of size n, insertion sort run in 8.n⁴ steps, while merge sort runs in 64 n.log n steps. For which value of n does insertion sort beat merge sort? So all we have to do is that we want to this part of equation be larger than this part, actually, like this. Yes, first we can simplify this equation and actually like this, and we can write this with this form. And after that we can simplify n's from both sides, so it will become like this. And then we want to solve this part of equation. So let me first tell you, based on the rules that we have for logarithm, we can write this like this, actually. Yes, like this. So actually it will become something like this, and ln, and we use from n here, and ln2. We will move ln with a number 2 to other side of the equation, actually, and it will become like this. And this is ln n. And after that, for solving this problem, we will use from actually one replacing, and we use from this equality as our assumed. So n is equal to neper to power of x, so it will become like this. And if we want to rewrite the equation, it will become like this here: e power 2x ln2 and divided by 8 is greater than, actually it will become like this. And we know that this part is equal to x, so yes, like this. For rest of the question, we will move e power 2x to the other side of the equation. So after that we have something like this, actually is greater than x dot. Here we want to use from actually the Lambert function for solving this problem. If you want to use from this function, actually the form of this actually function is something like this. If we have x dot e power 2x equal to 0, we know that the value of is equal to the Lambert function of y, like this. So all we have to do here is that we have to multiply minus to both sides of the equation, so it will become like this. Sorry. yes, here and here, and yes. And this is the form that we have. Actually, here we can assume that we have the equal symbol here, and both sides of the this equation are equal to each other. So after that, if you want to write it as a Lambert function, it will become like this. We have minus x is equal to Lambert function of minus ln2 divided by 8, and this is equal to, x is actually equal to, sorry here, minus of Lambert function of this value here. And actually we know that based on this, assume that we write it here, x is equal to Neper to power of n is equal to Neper power of x. So actually after that, if we replace the values, our final value is something like this. The value of n is something like this. And actually we can assume that this is equal to 5 because they are so near together. So for the value of actually something like 45, the insertion sort, our insertion sort will running faster than merge sort. And that was the answer for second question. Here let's move to third and final question. The final question is that what is the smallest value of n such that an algorithm whose running time in 100.n to power of 2 runs faster than an algorithm whose running time is 2 power of n on the same machine? So actually for solving this equation, I used from the Python and SymPy library that we have in Python, and I actually read and write this code. As you can see, I import SymPy as sp and define our variables here. And actually, I define our equation later and solve it with numerical methods that we have in SymPy. And our answer is something like 40.32, 47, and etc. So the answer for this part is actually 40 dots, actually let me say it again, yes, 32. This is the answer for this part. And for solving it all, actually we did was that we define our equation like this. 2 to power of n is equal to 100 dot actually product to n to power of 2, and yes, all we did that we solved this equation. And this is the answer for third question and final question in this section. I hope you guys enjoyed this video and learned something. Actually this part was we used from mathematics, we used from Lambert function for solving these problems here. But actually after this part, in other section, we will start coding and implementing the something like insertion sort, I don't know, merge sort, and other things that we will see in this book. And yes, if you like this video, like it, and if you have any comments for me, leave it in the comment box. And if you like it, you can subscribe to my channel. And yes, that's it. Have a nice day, guys. Goodbye.